Hello, everyone. Thank you for tuning into this webcast today. Our topic in this cloud webinar series is solving the PAR replenishment puzzle for healthcare. And although healthcare is the focus for this particular webinar, this tool can also be applied to other industries as well. Presenting today's content will be Kevin Martins, VP of Sales and Strategy from AVATA, and Thomas Zerzicki, Practice Lead for Cloud ERP at AVATA. And now I'm going to turn it over to Kevin, who will give you a brief introduction to AVATA for those of you that may not know us yet. And then we will get right into our topic of discussion for today.
Thank you, Deb, for that introduction. Okay, so AVATA is a full-service consultancy firm specialized in Oracle software and cloud applications. We do full ERP, meaning financials, manufacturing, inventory, procurement, etc. We also focus on enterprise performance management, or EPM, in the cloud, and all aspects of supply chain management, or SCM, in the cloud as well. We will work with our clients on any additional PaaS services during our implementations that we do. We have several areas that we focus on. We look at overall solutions with the clients. A little bit about this is if a customer is looking for solutions that require a SaaS or a PaaS environment specific to their industry, we can help develop that and have it either specialized for their install, or you can find it on Oracle's marketplace. Additionally, we provide management business consulting, where we are agnostic to the software tools that a customer might be looking at. We help come in and do blueprint exercises or assessments for customers to understand if they need the cloud environment and what applications make sense for them and at what time. All of our implementations include some level of managed services. We provide hypercare support after the implementation is completed, and then we also look to having managed services as a component after the implementation to help augment a customer's staffing or support areas once they go live. All of our implementations include some aspect of educational and training components to make sure that when we leave, you're up and running and using the cloud applications fully, and your team is able to kind of do this on their own. So what separates AVATA from other partners that are working with Oracle? One of the first and foremost things is our people. It's our deep expertise in the industry knowledge, and this comes from our people, where a bulk of the consultants that we use with AVATA are coming from industry. We've been in your shoes before. We've performed planning. We've been in the demand planning aspects of things. We've used the Oracle applications, and we're very familiar with what it takes not only to use the actual application itself, but understand what kind of things you're trying to gain from using the applications and streamline the processes that are happening in your company. We also recognize that future success of AVATA is hinged on your success. We target 100% customer satisfaction. This is for referenceability as well as customer success understanding. We look to work with customers both in future conferences as references for other customers and for future work as well. Third, our strategy. We look at how we've done the integration. We look and see where Oracle's going in the future with cloud. And we understand that all these things come together to not only look at the uniqueness of the client that we're working with, but our solutions that we're bringing to the table. And that's really where we get our tagline, where strategy meets execution. And finally, it's our solutions. We look at business processes, our technology aspects, both integration and other components that we might be looking at, and bringing in industry solutions that we've brought in from working with many, many other clients over the past 20 years of our history to create a solution that works best for your model. Next, I'd like to turn it over to Thomas Zerzicki, who's going to talk about the technical components of the cloud environment for this webinar.
Thank you for the introduction, Kevin. Welcome, everyone. Thanks for joining the webinar today. Today, we are going to discuss opportunities for a significant improvement of PAR locations replenishment process specific to the healthcare industry. There are multiple industry verticals which may benefit from the methods, and software-driven approach that we're going to cover today. But we believe that the problem and our response is best visible, can be best demonstrated in healthcare. As such, we will start with an industry perspective of on how power locations are replenished, describe automation opportunities, and describe how implementing a similar solution led to substantial process improvements for one of our clients. With that industry and process overview, we would then describe how a proper combination of Oracle supply chain management, specifically planning, inventory management, purchasing modules, should allow for reaching automation and stock availability improvement goals. Finally, we would like to describe the process model and our own implementation accelerator that allows healthcare systems implement Oracle solutions very quickly and adopt leading industry practices in a managed, prescribed, and efficient manner. Second part of our webinar is a demo or a walkthrough, live walkthrough of the solution. So with that introduction, we believe that the fundamental challenge we are facing when it comes to periodic location replenishment in healthcare is that it's really hard to strike a balance between need for availability of medical supplies when and where they are needed, and need for optimization of the inventory level. And typical answer, which is power locations replenishment, may be lacking in accuracy and typically demands an extra manual effort from administration through nurses and physicians. And we also believe that there's an inherent inefficiency in power location replenishment. A typical model is caused by insufficient demand planning. That in turn demonstrates itself in medical surgery shortages, possible expiration, or material obsolescence problems. So if we are planning to improve the replenishment process, let's think about it. Let's think about a method of improving the demand planning accuracy that would result in reducing obsolete and unneeded inventory balances, but without impacting the desired availability and not increasing the level of manual labor needed. Those objectives may be extremely hard to be met all at the same time, especially when looking at a typical replenishment systems landscape. So with all the limitations of legacy inventory systems, data availability, and also cost barrier, especially related to implementation of new inventory systems and inventory modernization. So to summarize, the background landscape is that we are dealing with inventory planning inaccuracies, typically manual complex process. Data might not be available or might not be good enough for proper planning, and there is a technology barrier, all that leading to high costs, worst case, obsolete or materials or lack of proper availability. So with that, let's take a look at the opportunity there. What does it look like industry-wise? We believe that the problem may be substantial. And one of the most recent studies called out here suggested that over 50% of inventory holdings are inactive and 10 may be obsolete. And further, 40% of hospital systems operating expenses may be related to supply chain. Finally, there's the accounting side of the problem. From the purely accounting standpoint, the inventory levels may be understated. What hospital systems typically store in stock may be up to 250% of what actually is reflected on the balance sheet. So there is a substantial opportunity, even with small improvements in forecasting accuracy. On average, even 5% improvements may lead to a 4-day reduction in inventory. And in the reference study covering over 270 hospitals over 4 years, that small improvement in accuracy led in turn to 50% greater inventory turns, averaging over 70 turns per year. This improvement opportunity, or lack of precision in PAR replenishment planning, is also recognized by industry leaders, with clearly seeing deficiencies we mentioned earlier, all of them noted on the left-hand side of the diagram. So that suggests that the current replenishment methods may be unacceptable or suboptimal. With that, we are going to now take a quick look at automation opportunities and how they can be mapped to the whole supply chain in healthcare. We can now see that stocking decisions and replenishment signals can be crucial to outcomes across the whole supply chain. So if we have suboptimal or inaccurate replenishment methods at the very, very end of the chain, so in PAR locations, storerooms, on the clinic floors, at the end of the chain, then those incorrect signals or late signals would have an impact on the whole chain. So all the way up to distribution centers and or suppliers. And the problem, we believe, is visible for all suppliers or supply types, from medical, surgical, through pharmacy supplies. The fundamental problem and the reason for that cascading effect is that most of the storerooms at the end of the chain are PAR locations with no quantity tracking. As such, we don't have a real-time visibility into actual current quantity level for each of the stored materials or supplies. And obviously, that problem demonstrates itself in exactly the same manner for all types of locations and across the whole healthcare system, from community-based care, ambulatory procedure centers, diagnostic centers, urgent care clinics, through acute care hospitals. That's supply on each and every floor, supply for each operating room, and then post-acute care is affected equally. We at AVATA have addressed this problem at a number of our clients in the healthcare industry. We thought it would be maybe helpful and appropriate to provide you with a quick example how implementing replenishment planning and demand management based on Oracle software for a large system like Kaiser Permanente led to substantial and very, very visible results. Obviously, we were dealing here with a highly complex inventory environment with multiple regions, thousands of stocking locations, over 1.5 billion purchases per month, and over 200,000 items in the replenishment process. By implementing our solution, we were able to demonstrate that the payback period is very reasonable. In this case, it was less than a year, and just 8-point improvement in forecast accuracy led to over 20% inventory balance reduction and much better item availability. And with that, I would also like to sort of underscore and highlight the fact that better replenishment method may be equally a vital goal for a large organization like the one shown here, but also smaller healthcare systems where maybe the effect would not be shown immediately in a great inventory reduction, but maybe the goal, and equally important, if not even more important goal, would be in providing availability of medical supplies when and where they are needed. So let's take a look now that we have looked at the challenges in the healthcare industry and automation opportunities as they demonstrate themselves across the whole supply chain. Let's take a look and very, very quickly describe how planning and inventory management, specifically Oracle Cloud Planning inventory modules, can work together to dramatically improve and automate PAR location replenishment. With very recent release 20A of Oracle Cloud Software, Oracle provided a new module, a new set of features under Oracle Replenishment Planning Cloud module. This is an extremely powerful addition to both demand management and inventory management and purchasing in cloud, because it allows us to, for each point of use, we can use the consumption data and consumption history to forecast demand, feed the replenishment planning, and automate the execution of replenishment policy and automate creating the supply replenishment signals from inventory to procurement module. And with a powerful demand forecasting engine, a vital, critical part of the planning suite in Oracle Cloud, we have a vast array of tools available to us to make that demand forecasting based on consumption history extremely accurate. So we have over 300 engine parameters, multiple engine profiles, multiple statistical models to use. And one thing that is extremely powerful, also causal factor analysis that allows us to see how demand for specific segments in our supply chain or specific portion of our materials and supplies is correlated or driven by seasonality, external events that we can also track. This is just a brief list of forecasting methods that we use for different segments of supply. We're not going to, in this segment, we're not going to get into specifics behind each individual method. The purpose of this slide was just to give you all some appreciation for the range of possible forecasting methods that can be used in demand management. One thing that we mentioned earlier also is that the replenishment process or replenishment planning can then be organized by segments that just make sense from the replenishment standpoint. And in this case, we have a breakdown of supplies to classes or categories, hypodermic needles here, then down to items and mapped to individual locations, facilities, and then and stores, operating rooms, or PAR locations. So we are able to see our forecast using those segments or categories, and also drive the review of the replenishment policy by looking at categories with the highest error or items with highest forecasting error, or look at locations that were in the past affected by inaccurate or insufficient supply, I should rather say. So what exactly can we do between planning and inventory management to improve the forecasting quality, and how planning and inventory management can exchange information so that we can automate the PAR replenishment process? Well, looking at those three pillars here, we have planning, integration layer, and then on the right-hand side, inventory management. We have depicted the flow of information going from the left to the right-hand side of the diagram. So first, we can feed planning module with obviously master data, but transactional data that can allow us to produce a forecast. In this case, since we don't have real-time inventory quantity for each location, remember, PAR locations are typically not quantity tracked, we can feed planning modules with the shipment history per item and per location. That's depicted on the left-hand side of the diagram. Further, we can also feed planning module with auxiliary data. So maybe correlated data streams, such as medical procedures performed in a location in a given period of time, or the data directly from sensors, smart shelves, and other data that may allow us for better forecasting accuracy. Based on consumption history, and that's the first block from the top in the planning cloud pillar, forecasted demand based on consumption history, and then preview the replenishment policy for item location segments. And if we are happy with that replenishment policy analysis, execute the replenishment policy by sending updated PAR levels or min-max signals to inventory. Between planning and inventory management, the integration layer, just like I described a moment ago, would automate the PAR level, PAR maximum quantity updates. It can also trigger count events in inventory management, or if at some point of implementing that model, we are happy with the quality of the produced forecasts, planning can also send direct signals and automatically create supply orders. That is depicted in using three arrows, three flows between planning and ERP planning integration. Based on the signals from planning in inventory management, we can perform visual check or perform count when it's needed, when it needs to improve the accuracy of forecasts, and then use new PAR levels, count data to create supply orders, or go directly to supply order execution, which between inventory management and procurement can result in creating purchase order directly to supplier or transfer order from, let's say, distribution center to the end PAR location. So this brings us to our AVATA Accelerator. So a solution that we created to address that very need and address the need for automating PAR replenishment. And I would like to briefly describe what it is and how we believe it would accelerate the process, the implementation process, and implementing Oracle Cloud Planning and Inventory Management and Purchasing. So first and foremost, PAR Inventory Replenishment Express is just one of the few accelerator solutions that we have developed and currently available in our offering to speed up the transition or implementation of new Oracle Cloud modules. And what it is, it's both a tool set that speeds up Oracle Cloud Planning and Oracle Cloud Inventory module implementation across all steps in the implementation process. So specifically, using Oracle Framework, we are able to evaluate the current master data, definition of locations, analyze the existing configuration in commonly used inventory management and purchasing platforms, including on-prem and legacy Oracle products such as EBS, PeopleSoft, and then suggest configuration that is in line with the leading PAR replenishment process that we described just a few moments ago. And then the accelerator also helps us in automating data migration from the legacy platform or currently used ERP package to Oracle Cloud. As such, we are able to compress the implementation timeline so that from the very, very beginning of implementation process, it takes days or weeks at most to stand up a solution that is able to produce a forecast and demonstrate using live data benefits from using Oracle Cloud solution, and then gradually implement that solution across the organization. So it's both a tool set, just like we described a moment ago, as well as a process model. And you can see on this diagram here that with AVATA Accelerator, we are essentially covering all possible exchanges between inventory management, demand management, supply planning, replenishment planning. That's on the side of producing a forecast, and then executing the signals from replenishment planning, supply planning in supply chain management part of the suite. So creating supply orders, turning them to order requisitions, and then based on purchase agreements data, automatically creating purchase orders, sending them through EDI or supplier portal to suppliers, and then receiving medical supplies or pharmaceutical supplies that we created based on the signals from replenishment planning, and using that shipment again in feeding demand management, supply planning, and replenishment planning with data, new data to improve the forecast. It's both a tool set to accelerate the configuration process and the implementation process, as well as leading processes and leading business practices. In this part of the webinar, so we're going to try to walk you step by step through all those processes from the beginning to the end. So the first step in our walkthrough would be to obtain PAR location history and consumption. Typically, that history is represented by a number of measures in planning, and one mandatory element, one mandatory measure here is the shipment history. So that's the first row in our table. That's essentially shipment history for each individual or to all PAR locations covered by our demo. So we are tracking it in this example by item, clinic, store, and then day. The granularity of that data can be greater if needed. And one more thing that I would also like to mention, we covered that aspect of our model replenishment process in the earlier part, or the part one of our webinar, but we also have ability to use secondary or auxiliary data to improve the forecast accuracy from medical operations performed to data from intelligent sensors. So think smart shelves, intelligent stores, intelligent store locations, sensors that track weight of a bin or indicate access event to a storeroom. For the purpose of our presentation and our demo, the shipment history is the mandatory element. This is what we absolutely need to create a forecast, but we also would like to indicate that we can use additional measures, additional data points to improve accuracy if needed or if available. So coming back to our model, the essential part of that first step, since we don't have real-time inventory counts or real-time quantities for each PAR location, the way to generate forecasts would be to grab all shipment history to individual locations and send it over to demand management. Let's take a look at how it can be done in the system. So we start with item definition Oracle Cloud. In this case, it's a syringe. You can see that it has both primary and secondary unit of measure, so it can be tracked by eaches, by individual units, as well as boxes. We have defined multiple locations in our demo, so we have a number of facilities, Wondercare General Hospital, Wondercare Children's Hospital, and then operations organization. This is just to indicate that a definition of an item or a configuration overall can be shared across multiple facilities and locations. So all of them can share the same set of tools and same shared item catalog. Let's now move to individual sub-inventories definition, so individual locations. You can see that for one of our hospitals, we have defined a number of sub-inventories, and each sub-inventory would represent a PAR location, so location that, as indicated on the screen now, is not quantity tracked. We have defined on the screen sub-inventory at item class location level, but typical use of that would be that we would have one single location, one single storeroom defined as sub-inventory. The important takeaway from that screen is, once again, the fact that, as you can see on the highlighted part of the setup, quantity track is not selected. So the system is not going to carry real-time quantity of items stored in a PAR location. The other thing that may be relevant for the purpose of our walkthrough is that there are several replenishment count methods from PAR through count through direct supply order, and our method and our process of generating forecast and planning based on shipment history can work with any of those replenishment methods in cloud inventory management. So the next step for specific combination of sub-inventory and item, we would typically start, if those levels are known, with a PAR level, PAR maximum quantity definition. So the important comment here is that, when we implement that target replenishment method, we would typically start with either simple min-max or classic PAR replenishment model. So only over time, in a gradual manner, we can introduce that refined model, and we will allow planning to update PAR levels. But typically for item category and location combinations, we would have a starting point that will then allow planning module to refine. As you can see here, in the next step, I queried the whole organization that was hospital number 1. I queried the inventory module for quantity of our item SY001, our syringe, and you can see that there's no quantity available, which is expected. Instead of that, we will use shipment history and other auxiliary sources of data to produce forecast. This is an example of shipment history for that location and that item that is available to us. And in this case, we can see 90 units shipped in January, 225 shipped in December. One thing that may be helpful is that we mentioned, possibility of using other sources of data that may be correlated with usage of medical supplies. So think of it, any other clinic systems or sensors, smart shelves, metering data that can be used to improve the forecast. Those are optional data sources. They may improve our forecasts, but they are not necessary. Shipment history in most cases would be enough. The next step would be to then look at effectiveness of our replenishment policy based on historical data per segment and per location. And the addition of replenishment planning module allows you to query and interrogate details of current policy execution and current PAR levels per segment and per location, as shown on the screen here. You can also see how replenishment planning based on historical data and forecasts can alert you to expected shortages per item category, per segment, per location, as shown on the screen here. In our replenishment plan definition, we can then, for each individual group, we can define our replenishment plan options and replenishment policy. You can see that in our example, we used several categories of medical supplies, each with a handful of items for the demo purposes. And we have defined the policy parameters. In our case, the safety stock calculation is defined as 20 days of cover. And the days of cover basis is the forecast that we're going to generate based on shipments history. That's on the right-hand side of the diagram. The other important element here is that even if you define the policy for a given segment, in our case, syringes, you can, on top of that, define exceptions to policy. So take it to a more granular level, in this case, item level. So the next step would be to run the replenishment plan, now that we have defined its parameters, refresh the data from the ERP package, so shipment history, and step 3, run demand plan. We can then preview the effectiveness of the current policy and make adjustments if needed. But one thing where it's really clear what Cloud Planning module is going to do is on this screen, where for a given item segment, you can see that the first row, we are providing shipment history from last year, and then shipment history 1 year ago. Those are the first 2 rows. We can also obviously have additional measures, so auxiliary data such as number of related or affected medical procedures performed. But in this case, we are showing just shipment history and shipment history 1 year back. Those are the first 2 rows. And then, after interrogating that data, you can see that based on the shipment history for each of the covered clinics and locations, in this case it's clinic number 2, PAR location 102, the system is going to generate shipments forecast for January onward. So based on shipments history that we have ingested from purchasing, inventory, package, whether it's legacy system or cloud inventory management, cloud purchasing, we can now turn that shipment history into shipment forecast. And obviously, if there is seasonality that is driving that forecast, if there are events that are observed in the past that would affect the forecast, would cause a spike in expected demands, we would see that relationship here would be able to drill down each forecast element to a causal factors level, where the system would explain what is causing or what are the factors affecting a given forecast point for a given month or period of time. And as you can see in demand management, we are using now the same segments, the same item categories that we used in our policy review in supply planning. And as a final result, or the final product of our process here, is that based on shipment history, the system is going to calculate new PAR level and new PAR max level based on that forecasted shipment, forecasted demand. And that data, highlighted on the screen here, can now be transmitted into inventory management and purchasing. We can further refine, based on policy analysis, we can further refine replenishment policy, rerun the plan if needed, but at some point we'll have new forecasted or recommended PAR levels that we're going to load to inventory management and procurement, so the ERP package. And the important note here is that, once again, we can roll out this new method in a gradual manner. We can combine the traditional methods based on min-max, traditional PAR replenishment methods, with replenishment based on signals from planning. We can roll it out by location, by storeroom, or item segments. If needed, and that's indicated in step 3 here, if needed, we can, at the very, very beginning of the journey, when we are still refining the forecasts, we can, instead of creating automatically a supply order, we can request a count or request visual check. So inject that additional verification element into the process, have human in the loop, or we can go straight to supply order and PO. And in this case, what is shown on the diagram is the fact that based on the forecast, based on the signal from planning, we are executing or accelerating the count, or we are asking for visual check for a given PAR location. But we can jump straight to step number 4, which is supply order generation. So based on signal from planning, we know exactly the quantity of a given item that needs to be replenished. And in our example, based on the newly calculated or refined PAR level, that requested quantity would be 46. So once again, to summarize, based on the consumption history, based on shipments history, we can use demand management and replenishing planning modules to recalculate PAR levels, load them, update them in inventory management and procurement package, and finally, in semi-automated or fully automated fashion, create replenishment signal that can then be turned based on data in the cloud procurement module or procurement package. That can be turned into purchase order requisition. If we have blanket purchase agreements with vendors, that supply order, then purchase order requisition would be turned into purchase order or purchase order release. And that purchase order obviously can be communicated. That's what you can see on the right-hand side of the diagram between supplier portal and EDI and suppliers, manufacturers. That can be turned into a visible document in supplier portal that suppliers and manufacturers can access. That's part of Oracle Cloud package. Or we can send an EDI message to our trading partner. So PO release, and then receive PO acknowledgement or shipment notification back. And obviously, PO acknowledgement and shipment notification can also be used to either create an alert notification or fine-tune the replenishment signal. If we know, for example, that a given supplier cannot fulfill our demand in the required time, or there's problem with supply on their end. In any case, the resulting outcome is a automatically generated purchase order, as shown here on the screen, with the quantity to be replenished taken from supplier order, generated based on the forecasted demand from the planning module. That concludes our walkthrough and our presentation. Just final thoughts to recap part 1 and part 2 of our webinar. In our view, using our model and Oracle Cloud software, PAR location replenishment accuracy can be dramatically improved using existing data. And in our example, shipment history, Oracle Planning Suite can automate PAR location replenishment. And obviously, the advantage here is a wide array of forecasting methods available in demand management in Planning Suite. Further, that improved accuracy can be accomplished without extra burden on medical and administrative personnel in your organization. And finally, lastly, our own accelerator solution allows for a quick time to value, quick implementation time frame from installing or subscribing to Oracle Cloud solution, ingesting the existing data, to producing forecasts and producing automated replenishment signals. Thank you very much for your attention and your time today. With that, I'll turn it over to Deb.
Thank you, Thomas. And that concludes our presentation today. As always, we invite you to contact us if you would like to know more or have questions on today's content. You can send us an email or give us a call. Please check out our website for resources relating to this topic, as well as future webinars. Thanks again, and have a good day.